Hello everyone, my name is Irtara Firza, and for this part of the presentation I'll be explaining the schedule comparison and the impact of the schedule reduction for our intelligent waste collection monitoring system project. For this slide, it shows the comparison between the original project schedule and the revised schedule after the client requested a 10% reduction in project duration. Originally, our project was planned to be completed in 184.8 days. After revision, we successfully reduced the schedule to 166.3 days, achieving the required 10% reduction without removing any project scope or deliverables. The reduction was focused mainly on the critical and near critical phases, particularly system design, development, testing, and deployment. Early phases such as initiation, planning, and requirements, as well as project closure, were kept unchanged to avoid risks related to governance, approvals, and final acceptance. This comparison demonstrates that the schedule was revised in a controlled and strategic manner rather than simply cutting time across all phases. Moving on to the next slide, this slide highlights the results of the schedule reduction in percentage terms for each phase. As shown in the chart, phases D to H experience a reduction of approximately 10 to 11%, which aligns with the overall project reduction target. For example, system design was reduced by 10.4%, mobile app development by 10%, dashboard development and testing by 10.7%, and deployment by 10.9%. Meanwhile, phases A until C and phase I show 0% reduction, as these phases are critical for project stability and quality assurance. Overall, this result proves that the revised schedule meets the client's requirement while still maintaining project quality, risk control, and realistic execution timelines.
Hi, my name is Aurelia and I am presenting the comparison budget for our project. This is the comparison budget table. Here you can see our original budget of 191,000 ringgit alongside the revised budget of 150,000 ringgit, which we achieved a 20% reduction. Each cost area was carefully reviewed for potential savings. Project management and planning was reduced from 2,130 ringgit to 1,700 ringgit, which will reduce the PM meeting hours, merging planning reviews. Next, we have requirements analysis, went from 2,900 ringgit to 2,400 ringgit, but by reusing the requirement templates from assignment 1. The third course area we have is the system design, which includes SA, UI/UX, and IoT. Went from 60,000 ringgit to 48,000 ringgit, which we reduced the design's alterations, consolidating the architecture reviews. Next, we have the development cost went from 50,000 ringgit to 46,000 ringgit through the code use and parallel development. Testing and QA was reduced from 29,000 ringgit to 22,000 ringgit, which we replacing the repetitive manual testing with automation. The second last we have is deployment and training, went from 25,000 ringgit to 20,000 ringgit. We replace physical sessions with the online training materials. Lastly, we have the closure activities, which dropped from 15,000 ringgit to 12,000 ringgit through incremental documentations during execution. On the next slide, we have revised budget chart. This bar chart visualizes the magnitude of cost reductions for each area, scale out of 50. You can see the testing and QA shows the largest reduction, while other areas like system design and development also contribute significantly to the total savings. Overall, this reduction were achieved without compromising project scope or quality. By optimizing processes, reuse templates, automating testing, and leveraging online deployment strategies, we successfully reduced the total cost by 20% from 191,000 ringgit to 153,000 ringgit. So that concludes the budget comparison.
Hello, my name is Irina and I will be presenting the risk identification framework. Authoring of the framework consists of 5 phases which are conceptualize and initialize, developer project charter and plan, execute and control, close project, and also evaluate project success. First phase, we identified the risk of stakeholder misalignment on the project MOV, which leads to scope changes early of the project. So the owner assigned for this risk is Irina Irwansteady, which is the project manager. The strategy to overcome this risk is by launching a meeting with the sponsors, the DBKU, validate the MOV metrics of 90% overflow, and document the agreements in minute meetings so that the agreement can be monitored during upcoming meetings. Next phase, the risk identified is the addition of outsourced developers in the budget, which causes an overrun of the budget lah. The owner assigned for this risk is Itera Firza binti Rosman, which is the system analyst. So the strategy to overcome this risk is by using a bottom-up estimation with expert input from the IoT specialist, and then a 10% contingency fund is spared from 200,000 but then the WBS of the actual and also plan is reviewed. For the next phase, the risk identified for that phase is IoT sensitive failures, issues in tested site, which it causes delays in the dashboard, and also the route optimization testing. Owner assigned for this risk is Aurelia Elena Anak Philip, which is the IoT specialist. So the strategy to overcome this risk is by purchasing spare parts of the hardware. Deployment testing can be done before the establishment phase. The risk identified is incomplete handover of documentation, which causes the DBQ rejecting the acceptance criteria. The owner, Yeoman Nathaniel Jungkook, which is the QA engineer. Strategy to overcome this risk is by developing an SRS report and manuals iteratively by using Agile and secure the sign-off from the DBKU. After the stage demo, risk identified for the last phase is failure to meet post-deployment metrics of 25% efficiency of the routes, which hinders the sustainability goals. So the owner assigned for this risk is Dayang Nur Shamina binti Ang Tumbun, IUX designer. Strategy to overcome this risk is by setting up a 6-month monitoring of the Google Maps API and compare it with each route efficiently. Change the routing algorithm if efficiency falls below the target of 25%.
So let's talk about the conversion strategy of our choice. We chose the phase conversion, and the idea in mind, the goal in mind is that instead of changing the whole city at once, we will roll out the system zone by zone. So, for example, from zone A, we will go an agreement into zone B, zone C, and then in the end, it will be implemented into the full city. So the question being, why did we chose the phase conversion strategy? Well, for number one, because of logistics, it's hard to install hardware in a short amount of time. So um, we also can't do it overnight, so it will take time. So we'll do it zone by zone. And the second reason is being the risk control. For if there is a route bug occurs or any bugs occurring during the implementation of the specific zone, it only affect that one zone. It doesn't affect the whole city. And the third one, the last one is training. This strategy it allows us to refine our driver training before the full launch. And finally, we approached the rejected alternatives. We rejected the direct cutover because it's too risky and it's too dangerous for critical public service. We need a safety net. And if the system fails, there's no backup. The second one is the parallel conversion. It is not impractical. It is impractical, and it is operationally impossible for a driver to follow a fixed manual route and a dynamic optimized route simultaneously.
For project closure, we use a structured checklist to ensure the IWCMS project was formally and professionally completed. First, under technical completion, all system modules were tested, fully integrated, and verified for performance and security. Next, documentation and training were completed, including finalized system documents, user manuals, and training session for DBQU staff. Then, for administrative closure, the final project report was approved. The budget and contract were closed, and formal sign off was obtained from DBKU. Finally, for operational readiness, the system was deployed to the live environment. Monitoring was activated, and the system is ready for daily operations. After deployment, the system is evaluated using measurable organizational value (MOV) to ensure it delivers real benefits to the BKU. Service effectiveness is measured through fuel bin overflow and faster response time. Operational efficiency focus on optimized collection routes and reduced travel time. Cost reduction is evaluated by lower fuel usage and reduced operational expenses. System reliability ensures stable performance with high uptime monitoring, while stakeholder satisfaction is measured through positive feedback from the BKU and fewer public complaints. The MOV timeline is conducted over three stages: after 1 month for initial performance checking, 3 months for midterm review, and 6 months for final validation. If any targets are not achieved, corrective actions such as system optimization, additional staff training, and improved operational procedures will be implemented.